to this video tutorial involving logarithms. We're going to look at several problems here and solve them together. Now remember that a log is an exponent. So here the base is x, the exponent is 3, and that's just equal to the other number that we have. Now we would be thinking, what number multiplied by itself 3 times is equal to 64? You might have to brush up on numbers a little bit, and some of this stuff could be on a no calculator section of an assessment. But 4 times 4 is 16, and 16 times 4 is 64. So 4 is the number that when we multiply it by itself 3 times gives us 64. The next problem that we're going to look at. Again, we're going to convert it out of a log and into an exponent. So here it's going to be that 5 squared is equal to x. Well, that's simple enough. That means that x is equal to 25. Next problem. Log base 3 of 9 equals x. That means 3 to the x, because the log is equal to the exponent, is equal to 9. Well, 3 squared is 9, so x would simply be equal to 2. In our next problem, the log base 25 of 5 is equal to x. Convert it out of logs first, so the base is 25. The log is always equal to the exponent. Now here, be careful. The square root of 25 is equal to 5, so the exponent that we want is 1/2. And as we continue down the list, on this problem, again, we'll transfer it into an equation. X, the base, the log is equal to the exponent, so the exponent's 4, is equal to 16. What number to the 4th is equal to 16? Well, that'd be 2. 2 times 2 times 2 times 2 is 16. You might argue that negative 2 times negative 2 times negative 2 times negative 2 is 16, and while that's true, we don't allow the base on the log to be negative in this class, so we'll just go with the answers highlighted in yellow. A next set of problems now appears on our screen. We will do the same thing. So here, 81 to the 0.5 is equal to x. Now think about that for a second. That's 81 to the 1/2, which would be the square root of 81. So in that case, the square root of 81 is equal to 9, and that would be our value of x. So it will tie into our fractional exponents as we see in the next problem. 64, the log is equal to the exponent. It's equal to the other thing then. So this means that x will be equal to the cubed root of 64. Well, 4 times 4 times 4 is 64. So x would just simply be equal to 4. Next problem gets a little tricky. So transferring this out of logs, we get 125. The negative 1/3 would be the exponent, and that's equal to x. Now be careful. Negative 1/3 power means reciprocal it. Then the 3 in the denominator means we want the cubed root. And the cubed root of 125 is 5. So in that problem, x would be equal to 1/5. Next problem. Well, again, transferring out of the log, we're going to have x to the 0.5 equals 25. What that means is that the square root of x is 25. To get x by itself, we would need to square both sides. X is equal to 25 squared, and 25 squared is 625. So x in that case would be equal to 625. And this next one, the log base x of 100 is equal to 2. Transfer it out of logs. X, the exponent is 2. That's equal to 100. So if x squared is 100, we would take the square root on both sides. Now, we don't put the plus or minus in because we don't allow the base on the log to be negative. So in this case, x would just be equal to 10. Now really the other thing we did with logs is we used them to solve equations like we see here. To do that, first thing you need to do is isolate the thing with the exponent. So we will subtract 8 from both sides to start this problem off. 142 minus 8 is 134. Then we will divide both sides by 5. And now we're going to convert it into a log. So be careful. Here this would be the log base 7. It's equal to the exponent, which is 3x minus 1. And the thing that will go inside of our log is the 134 over 5. So now we would add 1 to both sides. It would be the log base 7 of 134 all over 5 plus 1 equals 3x. And then to get x by itself, we divide by 3. So x would be the log base 7 of 134 all divided by 5 plus 1 all over 3. On a test or a quiz, I will ask to see that format, and then I will also ask for the decimal approximation. So how we get the decimal approximation? Well, first of all, to do this. Now, if your calculator doesn't have the nice base option with logs, we type log of whatever's inside, 134 over 5, and then we have to divide that by the log of 7. That gets us the first piece. Then we will add 1. We'll take that whole decimal and we'll divide it by 3. And the answer that we're going to get there for x is 0.8966. I'm going to put 0.897. Now if we really wanted to check that and see if it worked, what we could do is we could store that value as x, and then we could go up to the original problem. We could type it in and make sure that it works. So 5 times 7 raised to the parentheses 3x minus 1. Now the calculator is storing that value of x plus 8. If we're correct, it should be 142. Oh, look at that. We're correct. It does turn out equal to 142. A nice way to double check yourself and to know that this is correct. I would need to see both forms, the form that I have highlighted in yellow and the form that I would have highlighted in green as the answer on a test or any other assignment. That's how we work with logs. We can use logs to evaluate expressions and to solve for variables in an exponent.